Good day, learners! Welcome to Mathematics Alps Bridging Camp. I am your teacher, Mr. Lordson Q. Shani. And today, I'll be sharing another exciting topic for this session. But before that, I'll be sharing first our objective. After going through this topic, the learners are expected to illustrate a geometric sequence. But before that, let's have our warm-up first. The concept of ratio is needed to understand this kind of sequence, which is the geometric sequence, and the process on how they are generated. A ratio compares two quantities by division. A is to B is equal to A over B, or A divided by B.
Now, let's have further example. Find the ratio of the second number to the first number and find the answer. Take note, you will be finding the ratio of the second number to the first number. So the first numbers are 2, negative 49, negative 5, and 81. For the second numbers are 8, 7, negative 25, and negative 9 respectively. Now, example in number 1 is done for you. The first number is 2 and the second number is 8. According to the instruction, find the ratio of the second number to the first number. Therefore, R is equal to the second number over the first number. So the second number is given, which is 8. So just replace it. And the first number, which is 2. So just substitute. So what could be the lowest term of 8 over 2? Both can be divided by 2. 8 divided by 2, that is 4. 2 divided by 2 is 1. So that's actually 4 over 1. Or simply 4 divided by 1 is 4. And that is your ratio. Example in number 2 is also done for you. The first number is negative 49 and the second number is 7. So R is equal to the second number divided by the first number. So 7 is the second number and negative 49 is the first number. So 7 over negative 49. What could be the lowest term? Both can be divided by 7. 7 divided by 7 is 1. Negative 49 divided by 7 is negative 7. Therefore, your answer for your ratio is 1 over negative 7. Now, can you answer this question number 3? The first number is negative 5 and the second number is negative 25. Take note, second number divided by the first number. What could that be? How about number 4? The first number is 81 and the second number is negative 9. So, second number divided by the first number. What could that be? So these are the answers. So obviously, the second number is negative 25 divided by the first number, negative 5. The answer is 5. And that's your ratio. Because, like sign. Therefore, it's positive. Now, for number 4, negative 9 divided by 81, the lowest term is negative 1 over 9.
So our main topic is all about geometric sequence. But do you know this geometric sequence? According to the definition, geometric sequence, it is a sequence of numbers where each term after the first is found by multiplying the previous one by a fixed, non-zero number called the common ratio. Example, if I have here 2, 4, 8, 16, 32, 64, 128, and so on, is this a geometric sequence? To know more about that, let's have our illustrative example number 1. Raising ducks is a good source of additional income, especially when the area is near the lowland rice field. Pet's place is a perfect area for duck raising. When Pet starts raising the ducks, he makes a record of the production of eggs as his duck starts laying eggs. He made a tally of the number of eggs his ducks lay each day. The table below shows his tally.
The table below shows his tally. For day 1, there are 2 number of eggs. For day 2, 4 number of eggs. Day 3, 8. Day 4, 16. Day 5, 32. Day 6, 64. And day 7, 128. Now, what can you say about the numbers? Is there anything in particular that you have noticed? Let's look at these numbers closely. I have 2, 4, 8, 16, 32, 64, 128, and so on. From the numbers, we can say that the second number is twice the first number. This means that 2, the first number, multiplied by 2, is actually 4, and that's your second number. Again, look at the third number, which is 8. Isn't it 4 times 2 is equal to 8? What about 16, the fourth number? Isn't it equal to 8 times 2? Now, so we can make a table of the following numbers. 2 for the first term, 4 for the second term, and that is 2 times 2, 8 for the third term, 4 times 2, 16, that is 8 times 2 for the fourth term, 32 for 16 times 2 for the fifth term, for the sixth term, 64, that is actually 32 times 2. And for the seventh term, 128, that is actually 64 times 2. Based on the table above, can you determine the number of eggs pet pig stock will lay on 8 and 9 days? Let's do it together. Of course, it will be better if we present the numbers in a table again. For day 1, the number of eggs are 2. That's your first term. For day 2, the number of eggs is 4. Therefore, that is actually 2 times 2. Here. For day 3, that is 8. Therefore, that is actually 4 times 2. For day 4, that is 16. That is actually 8 times 2. For day 5, that is 32. That is actually 16 times 2. For day 6, 64. That is actually 32 times 2. For day 7, 128. That is actually 64 times 2. Now, can you guess the number of eggs in day 8? How about in day 9? Are your answers 256 and 512 for the 8th and 9th days, respectively? If yes, then you are doing great.
Let's have another illustrative example too. Examine the following sequence of numbers: negative 2, negative 6, negative 18, negative 54, and so on. What can you say about it? Observe the pattern. All numbers are negative. Looking at these numbers, we can say that there is a commonality among them. What could that be?
Let's put the numbers in a table as in negative 2 as your first term, negative 6 as your second term, and that is actually negative 2 times 3. For third term, it's negative 18, and that is actually negative 6 times 3. And fourth term is negative 54, that is actually negative 18 times 3. Based on the examples, what can you say about the sequences of numbers we worked on? We could say that they are sequence wherein each term after the first can be obtained by multiplying the preceding term by a constant called the common ratio, denoted by R. So example number 1, the constant is 2. Can you see? This is the number that we use as multiplier to get the succeeding terms. In example number 2, the constant is 3. Here, this is the number that we use as multiplier to get the succeeding terms. More examples for geometric sequence. Letter A, solving the common ratio. If I have here geometric sequence negative 2, negative 8, negative 32, negative 128. What could be the process of getting the common ratio? For the solution, it can be the second number divided by the first number, that is negative 8 divided by negative 2. Both are negative, therefore, negative divided by negative is positive. So negative 8 divided by negative 2, that's actually positive 4. Or it can be third number divided by the second number. So negative 32 divided by negative 8, that is positive 4 again. Or the fourth number divided by the third number. Negative 128 divided by negative 32, that's actually 4. Therefore, your common ratio for your R is 4. Now, example number 2. Negative 3, 9, negative 27, 81, negative 243. Take note of the pattern. Negative, positive, negative, positive, and negative. So, for the solution for getting the common ratio or R, second number divided by the first number. 9 divided by negative 3, that's negative 3, unlike sign. Or the third number divided by second number, negative 27, divided by 9 is also negative 3, unlike sign again. Or 81, the fourth number divided by the third number. So 81 divided by negative 27, that is negative 3 again. Or the fifth term divided by the fourth term, negative 243, divided by 81 is also negative 3. Therefore, your common ratio is negative 3. Now, illustrating geometric sequence given the first term and the common ratio. So the first term is given, which is 3, or a sub 1. Common ratio is 2, or your R. So your a sub 1 is 3. Now, to find a sub 2, or second term, multiply the first term and the common ratio. So 3 times 2, that is actually 6. Now, the answer 6 here, multiplied again by the common ratio, which is 2. Therefore, 6 times 2 is actually 12. 12 again for the fourth term. 12 times 2, that is 24. So 24 times 2 is 48, and that is your fifth term. Therefore, I can form a geometric sequence which is 3, 6, 12, 24, and 48. Now, example number 2. If I have here first term negative 1, or a sub 1 is negative 1, and your R is 3. Therefore, your a sub 1 is negative 1. That's given. So for a sub 2, negative 1 for the first term multiplied by your common ratio, which is 3, that is negative 3, because that's unlike sign. So again, for a sub 3, the answer negative 3 multiplied by 3 is negative 9. For a sub 4, the answer negative 9 multiplied by the common ratio 3, that is negative 27. And the fifth term, negative 27 multiplied by 3 in your common ratio, that is negative 81. So I could form a geometric sequence which is negative 1, negative 3, negative 9, negative 27, and negative 81.
Now, your turn! Let's have our exercises. Exercise 1A. Extending geometric sequences. Find the next three terms in a geometric sequence. 1, 4, 16, 64, and so on. Step 1. Find the value of R by dividing each number or each term by the one before it. 1, 4, 16, 64. So we need to divide each term by the one before it. 64 divided by 16 is 4. 16 divided by 4 is also 4. And 4 divided by 1 is 4. Therefore, the value of R is equal to 4. Exercise 1B. Find the next three terms in the geometric sequence. 1, 4, 16, 64, and so on. Now, step 2. Multiply each term by 4 to find the next three terms. So if I have here 64 multiplied by 4, it's 256. 256 times 4 is 1024. And 1024 times 4 is 4096. Therefore, the next three terms are 256, 1024, and 4096. Exercise 2A. Extending geometric sequences. Find the next three terms in the geometric sequence. 5, negative 10, 20, negative 40, and so on. Observe the pattern. Positive, negative, positive, negative. Step 1. Find the value of r by dividing each term or each number by the one before it. So if I have here 5, negative 10, 20, negative 40, I need to divide negative 40 divided by 20. That is negative 2. 20 divided by negative 10 is also negative 2. And negative 10 divided by 5 is also negative 2. Therefore, the value of r is negative 2. Step number 2. Multiply each term by negative 2 to find the next three terms. So if I have here negative 40 times negative 2, it's positive 80. 80 times negative 2, it's negative 160. And negative 160 times negative 2, it's positive 320. Therefore, the next three terms are 80, negative 160, and 320. Thank you so much for listening. Have a great day. God bless.